Okay guys, so the purpose of this video is just to talk through this formula practice part 2. I'm going to start with just reading the problem. I'll point out what's given to us, our unknowns, and then I'll talk through the formula and work part of this. Okay, if you ever have questions for any part of this practice, make sure you're messaging me because we are not going through this in person. Okay, number 1 says, what is the acceleration of a skateboard that rolls down a hill from rest to 15 meters per second over a distance of 50 meters? Okay, so I've already highlighted our key words that will give us our givens and unknowns. So let's start from the beginning. It says, what is the acceleration? Well, it's asking us what acceleration is, so that has to be our unknown. Okay, so our unknown in this case is acceleration. And then it says that the skateboard is rolling down a hill from rest. So that word from reminds us that that's going to be initial velocity. And since it says rest, that means 0 meters per second. So our initial velocity is 0 meters per second. And then it says 2. Well, 2 tells us that we're looking for final velocity. So 15 meters per second is our final velocity. And then it outright tells us that we're looking at a distance of 50 meters. So we have D equals distance is 50 meters. If we look at our formulas, I'm going to look at, okay, where do I have initial velocity, final velocity, and distance? Okay, I look at the first one. I have initial velocity, I have final velocity, but no distance. So that's a no-go. The second equation, I have distance, I have initial velocity, I have no final velocity. So that one's a no-go. But I look at the third one. I have final velocity, initial velocity, and distance, all of those. Great, and I'm looking for acceleration. So it's in that equation. Awesome, that means that my formula should be that third equation. Great, now I have that third equation set up, but I want to solve it for my unknown. So first I subtract initial velocity from both sides, make sure it's still squared, and then I divide both sides by 2d. Because I want A alone, acceleration alone. For my work, I just take that last equation there and I plug in my numbers. So there I've plugged in all of my numbers to the appropriate places, and I plugged in my calculator, and that's what I get. Okay, now for number 2. It says a dog chases a cat for 35 seconds, accelerating at a rate of 5 meters per second. The dog started the chase at 2 meters per second. How far did the dog chase the cat? Again, I've highlighted all of the important parts of this question, so let's go through from beginning to end. So the dog is chasing for 35 seconds. If we look at that unit of seconds, that tells us that we want it to be a time. So under given, the first thing is time, is 35 seconds. Then it says that we have an acceleration at a rate of 5 meters per second. Again, look at those units. Meters per second is the unit for acceleration. So our next given is acceleration equals 5 meters per second squared. And then it says the dog started the chase at 2 meters per second. Meters per second is a velocity unit. So our 3 givens are time, acceleration, and initial velocity because it says he started the chase at 2 meters per second. But what's our unknown? Well, the last part of this question says how far did the dog chase the cat? Remember that how far is the phrase for distance. So our unknown is distance. Again, let's look at our equations now. Now we have time, acceleration, initial velocity. Okay, let's start from the first equation. So we have initial velocity, great. We have acceleration, fantastic. We have time, perfect. But now we look at our unknown. Do we have distance here? No, we don't, because that's final velocity. Okay, let's look at our second one. Do we have distance? Yes. Do we have initial velocity? Yes. Do we have time? Yes. Acceleration? For sure. So that second equation has all of the parts of our givens and unknown. So I'm going to be using that second equation for the formula. And it already solves for distance, which is our unknown, so I don't have to touch it. Okay, again, I'm plugging in all of my givens into my formula. So under work, that first step is plugging in all of my numbers. And then all I have to do is use a calculator, and that'll spit out the answer. So my answer is 157.5 meters. Okay, so here I've copy and pasted the top part of the worksheet again so that we can refer back to those equations. So, number 3 asks, Aaron Rodgers throws a football at a top speed of 25 meters per second. To throw the ball, he starts with the ball at rest by his head and reaches the top speed when he releases the ball, 1.5 seconds later. What is the acceleration of the football before it leaves Rodgers' hand? Okay, again, we have the highlighted parts, so let's go through. It says the top speed is 25 meters per second. Okay, well, we know that's a velocity, but we don't know yet if we want that to be our initial or our final velocity. So let's keep reading. It says that he starts with the ball at rest by his head. So because it says he starts the ball at rest, that means that that's our initial velocity. So rest means 0 meters per second for our initial velocity, which makes 25 meters per second our final velocity. Okay, and then it says he releases the ball 1.5 seconds later. So that's our other given. Time is 1.5 seconds. It asks us what is the acceleration. That tells us that we want our unknown to be acceleration. Okay, let's go through our options again for our formula. So we want initial velocity, final velocity, time, and acceleration. We've got final velocity, we've got acceleration, we've got time, we've got initial velocity. Oh, well, we got it right away. So the first formula there is the one we want to use. And again, we solved for acceleration because that is our unknown. Okay. So make sure when you're solving for acceleration here, you are showing as much work as you need to. So you can show just these 2 steps, or if you need to, you can write out the middle step where you have to do final velocity minus initial velocity equals that acceleration times time. All you're doing is sending that initial velocity to the other side. So when we do our work, again, I'm just plugging in my numbers. So I take this last equation we find, and I plug in my necessary numbers under given. Great. I plug it into my calculator, and that's what I get. 16.67 meters per second squared. Okay, and the last one, number 4. If a leaf falls for 48 seconds over 12 meters from rest, what is the acceleration of the leaf? Okay, so it's falling for 48 seconds. Well, that's a time. Again, look at that unit of seconds. It says over 12 meters. Well, meters is a distance. So we have distance is 12 meters. And it says from rest. So that means that it is starting its velocity at 0. So our initial velocity is 0 meters per second. It asks us what the acceleration is, so that tells us our unknown should be acceleration. Let's do our trick to find out which equation, which formula to use. We're looking for time, distance, initial velocity, and acceleration. Let's start from the beginning. Final velocity. Oh, we don't need that. So the first equation is out. The second equation, it gives us distance. Great, we need that. Initial velocity, love it. Time, exactly what we want. And acceleration, perfect, and another time. So that's the second equation is the one we want to use. In this case, we don't want to solve that one for distance. We want acceleration, like our unknown shows. So this one we now have to solve for that acceleration. So first, we want to keep the whole part of that equation with acceleration on that on that right side all together. So that only leaves this front part to be moved to the left. So I did that first. I moved initial velocity times time to the left side. And then you take the 1/2 times t squared and scooch it to the other side. So that gives me the rest of that equation. I did not show my middle step because I did not need to. I remember doing that earlier together as a class. Again, if you needed to show that middle step, that's perfectly fine. I'd prefer you show more work than less. I need to know that you know what you're doing. Okay, and just like before, I take that last equation and I plug in my numbers. And then I plug it in my calculator and I get 0.01 meters per second squared. This is one of the times where it would not make sense to round to the first decimal point because then it would show 0.0 meters per second squared. But that's not true. This is telling me that I have no acceleration. But in reality, I have an acceleration, it's just really, really, really small. So you want to go to at least 2 decimal points, if not 3. Okay guys, thank you for tuning in. Please make sure you ask questions if you need to.